So in this question, we're going to be working with our forces in vector form. We've been told that the particle has a mass of 1.5 kilograms, and we've been told its initial velocity, the time that it takes, and its new velocity or current velocity. So let's just collect these. These are SUVAT variables like any other. The initial velocity, -2, 3. Final velocity, 10, -3. Unknown acceleration, and the time it takes is 3 seconds. So we're looking for the acceleration. We'll use v equals u plus at, and we'll just substitute these in. From here, we just need to make sure we can do some vector arithmetic and solve for a. So subtracting u from v, dividing that all by 3, that gets us acceleration for -2. We're also asking this question to calculate the speed of the particle when t equals 6. So what is the new velocity when t equals 6? We're going to make use of the same formula here. We're looking for v this time. The initial velocity from the question, we know the time is 6, and we found this acceleration vector ourselves. Okay, just looking for the resultant of this right-hand side now. So the components would work out individually. So the horizontal component, the I component, -2 plus 6 times 4. For the J component, it will be 3 plus 6 times -2. That gives us a velocity vector of 22 with -9. We're asked to find the speed, so this vector needs to be turned into a scalar, and that's just going to be Pythagoras. Okay, the magnitude of v is going to equal the magnitude of this vector, and that's Pythagoras. Square root of 22 squared plus 9 squared takes us all the way down to 23.8 meters per second. So that's 3 significant figures, meters per second. Okay, I've actually switched around the order of these. The question also asked us to find the magnitude of F. So the magnitude of F. So what force would this 1.5 kilogram particle have been under? Well, let's use Newton's second law. That force is going to be the mass multiplied by the acceleration. So 1.5 times the acceleration we found, that gives us a vector of 6, -3. We need to find the magnitude of this, so we're going to employ some Pythagoras again. So the magnitude of this vector is 6 squared plus 3 squared, and just into your calculator, that gets you 6.71 newtons. So this force is 6.71 newtons to move the particle in this way.